Welcome back to the deep dive. We are jumping straight into the deep end today with a scenario that I think is going to haunt the dreams of a few IT managers listening.
It's a total nightmare scenario, but honestly, it's the perfect case study.
So here's the setup from the source material. You're working for a medical research company. The mission is critical curing diseases, processing massive data sets, the whole 9 yards.
Right.
But the infrastructure,
Mm-hmm.
it's ancient. You have servers scattered all over the globe, sitting in closets in basements.
I've seen it.
And they're struggling to run the new analysis apps. Latency is killing your team. And physically flying out to upgrade hardware in 20 different countries is just, it's not happening.
That is the classic load and scale trap. You've outgrown your hardware, but the logistics of replacing it are actually way harder than the tech work. You're just stuck.
Exactly. So the mission for this deep dive is to solve that problem. We are looking at the solution proposed in the research, lifting those servers out of the basement and into the cloud using Azure virtual machines, or VMs.
But we need to set the stage properly here. This isn't just about, renting a computer online.
Right.
We are talking about replicating an entire data center, ecosystem, networking, security, storage, automation, all without ever touching a screwdriver.
Okay, so we're going to break down the planning checklist.
Yeah.
Specifically, the measure twice, cut once elements, the hidden costs that catch people off guard, and the tools to automate the whole mess.
Let's get into it.
Okay, so if I'm this IT manager at the medical company, my instinct, and I think the instinct of a lot of people, is to just log in to the portal and click Create Virtual Machine.
Yep, yeah.
I want to see the server running. I want to see the blinking lights, metaphorically speaking. But the source material basically screams, stop right there.
Yeah, that is the #1 rookie mistake. If you start by creating the VM, you've already failed.
That seems so counterintuitive. I want a computer. Why can't I just build a computer?
Because a server doesn't exist in a vacuum. It lives on a network. If you just deploy the VM first, Azure creates a default network for you, which is almost never what you want.
And you can't change it later.
Changing a VM's network after it's built is a nightmare. Often you have to just delete the machine and recreate it. So step 1 is always the network.
Okay, so we're mapping out the virtual network, or VNet. What are the actual constraints here? What messes people up?
The big one is IP address overlap. The documentation is really specific about this. If your office network, where you are sitting right now, uses the 10 by 0.00.x range, and you set up your Azure VNet to also use 10.0.xx,
You can't connect them.
you can never connect them.
Because the routers get confused.
Exactly. It's like having 2 houses with the exact same address in the same town. The mailman, the router, has no idea where to deliver the packet, so it just drops it. You have to carve out a unique address space in the cloud before you launch a single machine.
So you need a unique block of addresses.
Right, and once you have that space, you slice it into subnets, maybe one for your databases, one for your web servers, and you control the flow between them.
And this is where that term, Network Security Group, or NSG, comes in.
Yeah.
I see this acronym everywhere in the docs. Is this just a fancy word for a firewall?
Effectively, yes. Think of it as a bouncer, but a really specific one. It sits at the subnet level or even on the individual network card. It's just a set of rules. You can say, allow port 22 for SSH so admins can get in, but block port 80.
But by default, does it block everything or let everything in?
By default, traffic inside the VNet is allowed to flow freely, but traffic from the outside internet is blocked. You have to explicitly open the doors you want people to walk through.
Got it. So we have the map. Now, the sources bring up something that feels incredibly mundane. Naming conventions. I feel like we can skip this, right? Just call it server 1 and move on.
Oh, you absolutely cannot skip this. Server 1 is fine when you have one server. But when you have 5,000 VMs and you're trying to figure out which one is the production database for the cardiology department in France, server 1 gets you fired.
Okay, fair point. But is it just about being organized, or are there actual technical limits that force our hand?
Both. The gotcha here is Windows. If you are spinning up Linux boxes for your research team, you have 64 characters to play with. You can write a novel in the hostname.
And for Windows?
For Windows VMs, you're capped at 15 characters.
15? That's barely anything. Why so short?
It's a legacy NetBIOS limitation that still haunts us from the 90s, but it means you need a really strict code. The source suggests a formula: environment, location, instance, product, role.
So give me an example.
Something like DevAce's Web01.
Decode that. Dev is development. Dev is East, US Web is the role.
Exactly.
Yeah.
You can look at that string and know exactly what that machine is, where it is, and what it does without ever having to log in. It saves hours of troubleshooting.
You mentioned UCG's US. That brings us to location. For our medical company, with offices everywhere, I assume we just pick the region physically closest to the office to reduce lag.
Usually, yes. That's all about latency. You want the server close to the user. But there are two other factors the texts highlight that people forget. One is data residency.
Legal requirements like GDPR.
Exactly. If that patient data cannot legally leave Germany, you must pick the Germany West Central region. It doesn't matter if West Europe is cheaper, you have to follow the law.
And what's the other factor?
Cost. This is a pro tip that catches so many people off guard. The price of a server is not the same in every region.
Wait, really? The same digital product costs different amounts.
Well, it's not just digital, it's physical. Power costs, real estate costs, cooling costs, they all vary by country. A server in West US might be 10 or 15% cheaper than the exact same server in Brazil South.
So for things that aren't user-facing, you can shop around.
You can shop around the globe for the best price.
That is a solid takeaway. Arbitrage for servers. Okay, network is planned, name is set, region is picked. Now we choose the hardware. But it's not like buying a Dell where I pick the processor speed from a list. We have sizes.
Right. Azure groups them into series, and you really need to match the series to the job. Picking the wrong one is a classic way to waste money or just kill performance.
Let's break these down because there are a lot of acronyms here. If I'm just running a basic web server for the company intranet, what do I grab?
You want general purpose. It's the Honda Civic of VMs, balanced CPU and memory. It's reliable, good for testing, good for low-traffic apps. It just does the job.
But our medical company is doing heavy data sequencing. They're crunching numbers 2047. The Civic isn't going to cut it.
No, the Civic will choke. You need compute optimized. The ratio there is skewed heavily toward the CPU. It's built for raw processing power, batch jobs, that kind of thing.
And for the databases, the SQL Server is holding all the patient records.
Memory optimized. Databases love RAM. They want to load as much data into memory as possible so they don't have to read from the disk. These instances give you just massive amounts of RAM relative to the CPU.
I see a category here for storage optimized too. How is that different from memory?
That's all about disk throughput. Think big data, NoSQL, data warehousing, anything where you're reading and writing terabytes to the disk constantly. You need that high I/O. It's all about the pipe to the hard drive.
Here's a question I think a lot of people have. Let's say I mess up. I pick a general purpose VM and 6 months later, the app goes viral or the research gets complicated. Am I stuck?
No, and that's the beauty of the cloud. You can resize, but, and put a big asterisk here, it usually requires a reboot.
So it's not seamless. I can't just slide a bar and have more power instantly.
Not usually, no. When you resize, Azure often has to move your VM to a different physical host in the data center that has the capacity you asked for. That means a restart. So, don't do it at 10 a.m. on a Monday.
Good to know. Let's talk about money. The bill. The source material makes a distinction here that I found really interesting. Compute versus storage.
This is what I call the ghost cost. When you create a VM, you're actually creating two things. A compute resource, which is the CPU and RAM, and a disk resource, the storage.
So if I shut down the VM, say, over the weekend.
You start paying for the compute, that's true, but that disk, it's still holding your data. It's still occupying physical space on a drive in the data center. So you keep paying for the storage even if the server is off.
That is a classic trap. I can see someone thinking they stopped the billing clock only to get a surprise invoice.
That happens all the time.
Now, for the compute costs, we have pay-as-you-go, which is the default.
Which is great for testing or for really unpredictable workloads. But for our medical company, if those servers are running 24/7, 365, pay-as-you-go is just lighting money on fire.
So what's the alternative?
Reserved instances, or IIs. You make a commitment to Azure. You say, I promise to use this VM for 1 year, or maybe 3 years. In exchange for that commitment, they give you a massive discount.
The source says up to 72%.
72%. Imagine getting 72% off your rent just for signing a 1-year lease. If you know you need the server, you have to use RIs. It's negligent not to.
There's also a note here about spot pricing. Is that useful for us?
Spot pricing is like flying standby. You get unused Azure capacity for dirt cheap, sometimes 90% off. But, and this is a big but, If Azure needs that capacity back for a paying customer, they evict you
They just turn your server off.
with very little warning. So it's great for batch processing that can be paused and resumed, like our medical analysis maybe. But it's terrible for a database. You don't want your database vanishing mid-transaction.
Right. Moving to the storage side, the disks. We have standard HDDs, SSDs. What's the golden rule here?
The golden rule is, don't treat the cloud like a laptop. On your laptop, you have one C drive with Windows, your photos, everything. In Azure, you want to separate those.
Why? What's the risk?
Because the OS disk is disposable. If Windows gets corrupted or you want to upgrade the OS, you might want to just blow that disk away and start fresh.
And if your data is on there?
You're in trouble. But if you put your data on a separate data disk, you can just detach it, kill the VM, build a brand new one, and reattach the disk with all your data safe and sound.
It's modular, like having your data on an external hard drive.
Exactly. It separates the brain, the OS, from the memory, the data. Always keep them apart.
Okay, so we have designed the perfect machine. We know the network, the name, the size, the cost. Now we have to build it. The Azure portal, the website is the obvious way.
It's the visual way. Wizards, drop-downs, green check marks. It's great for learning. But for our medical company, migrating 500 servers, it's a trap.
Because clicking create 500 times is slow.
It's slow, and humans are terrible at repetition. You'll click the wrong checkbox on server number 42. You put it in the wrong subnet. This brings us to the concept of infrastructure as code, or IAC.
This feels like the biggest shift in the source material. We aren't building servers, we are writing recipes for servers.
That's a perfect analogy. You write a text file, a template, usually in JSON or a script. That file says, I want one Windows VM, size standard D2's A3 in East US. You feed that file to Azure.
And Azure builds it.
Azure reads the recipe and builds it perfectly every time. And if you need 10 of them, you just tell Azure to run the recipe 10 times. It guarantees that the test environment is mathematically identical to production.
The sources mentioned a few tools here, PowerShell and CLI for scripting, and Terraform.
Terraform is huge right now. It allows you to plan out the infrastructure and even preview the changes. It'll say, if you run this, I will create 3 VMs and destroy 1. It gives you a safety check before you commit.
So the role of the IT admin is changing. It's less about plugging in cables and more about writing JSON files.
You're managing logic, not hardware. It makes you so much more powerful, but you have to learn the tools.
Speaking of managing logic, let's talk about keeping these things alive. We're back to our medical company. They can't afford downtime. The text mentions availability zones.
This goes back to the location discussion. An Azure region like East US isn't just one building. It's usually a cluster of data centers. Availability zones are physically separate buildings within that region.
So they have different power grids, different cooling.
Exactly. Different power, different cooling, different networking. So if a backhoe hits the power line for building A,
Building B and building C are totally fine.
right, by spreading your VMs across zones, putting one web server in zone 1, another in zone 2, you can survive a whole data center level disaster.
But what if the disaster is bigger? What if Godzilla steps on the entire East Coast?
Then availability zones won't save you. You need site recovery. This replicates your data to a totally different region, say, from East US to West US.
The source made an interesting business point here. In the old days, you'd have to rent a second data center, fill it with servers, and just let them sit there gathering dust, just in case.
The zombie data center. It was a huge, huge waste of money. With site recovery, you're just paying for the replication of the data. You don't pay for the expensive compute part until you actually push the panic button and failover.
That's a massive cost saver. You only pay for the fleet when you actually need to drive it.
Precisely.
Now, what about when things are going too well? Traffic spikes, the servers are melting down.
Scale sets. This is the holy grail of cloud. You set rules. If CPU usage goes over 75%, spin up 2 more VMs automatically.
And when the traffic drops at night?
If CPU drops below 25%, delete them. You are elastically expanding and contracting your infrastructure to match demand. You only pay for what you need when you need it.
And sitting in front of all this is the load balancer.
Right, the traffic cop. And make sure that all the incoming requests are spread evenly across all those VMs so no single server gets overwhelmed.
Last piece of the puzzle. The safety net. Backups.
Azure Backup. And please, listeners, we need to distinguish this from snapshots. A snapshot is just a picture of the disk at one moment in time. Azure Backup is a managed service.
So it's smarter.
It manages retention, encryption, and most importantly, application consistency. If you just snapshot a running SQL database, you might catch it in the middle of writing a transaction.
And when you restore it, it's corrupted.
It's useless. Azure Backup talks to the database, says freeze for a second, takes the backup and says, okay, carry on. It ensures the data is actually usable when you restore it.
That distinction is vital. A backup you can't restore isn't a backup.
It's just expensive garbage.
So let's wrap this up. We took our medical company from a nightmare of aging, scattered hardware to a centralized Azure environment.
We planned the network first. We named things consistently. We picked the right sizes for the workloads, compute optimized for the number crunching, and used reserved instances to cut the bill dramatically.
We used automation to build it reliably, zones and site recovery to keep it online, and scale sets to handle the load.
It's a complete modernization. But I want to leave the listeners with a thought that struck me while reading the automation section.
What's that?
We talked about infrastructure as code. If you can define a server, a network, and a firewall in a text file, and you can version control that file just like software code, does the barrier between developer and IT admin even exist anymore?
That's a deep thought. If the infrastructure is just code, then the ops team are developers too.
Exactly. We're moving toward a world where DevOps isn't just a buzzword, it's the only way to operate. The person who used to rack servers is becoming the person who codes the servers.
Well, if you want to dip your toes into that world, the Azure portal is waiting. Go spin up a VM. Just remember to delete it so you don't pay for the storage.
Please delete it. Don't be that person.
Thanks for diving in with us. We'll see you on the next one.
Bye, everyone.